Okay. Good morning, ladies and gentlemen. What we're going to look at, it's a revision of section 1, which is electrical engineering, which you did in electrical engineering 1. The first thing that we're going to look at today is we're going to have a look at what ground is. This is a symbol for ground. Ground is a zero voltage reference point. Reference point. Now, very, very important, it tells you what is our reference. Now, to make a better example of it, we'll put a battery onto that ground. There is our battery, and we have connected negative to ground. What does it mean? It means our voltage would be like positive all over. This reference point tells us that. If we were to look at our voltage on an oscilloscope, it would be something of this nature. That would be our voltage here, which is the source, meaning that it's positive. Now, we do not only connect positive, sometimes we connect negative to ground. We do not only connect negative, sometimes we connect positive to ground. There's our battery. Now we're going to connect our positive to ground. Now looking at it, how's our things? Our voltage is negative. Now if this is your zero line, that's what you're going to get, meaning that your voltages are negative. Now that one itself sort of show you how do we go about our ground as a reference point. It can either be positive connected to ground or negative connected to ground. As you see, the voltages are different. Now we're going to have a look at another thing again. That would be AC. Now, the symbol of AC is straightforward. It's this one. Look at it in your textbook or whatever textbook you have looked. How does the symbol look like? Now, AC is something of this nature. I've drawn how many cycles there? 2 cycles. Now, very, very important, it's got this, which is our amplitude. Amplitude. Now, that's our reference point. Now, this sign, this part is the positive amplitude, this side is the negative amplitude. Now, looking at this little symbol and its 2 cycles which you have drawn, normally, if you are in South Africa, the AC is said to be 220 volts. Now, what are they telling when they say the voltage is 220? It actually means that it's an RMS value. Whenever you work with an RMS value, for you to know the exact amplitude, you must multiply this with the square root of 2. The square root of 2, it will tell you your peak, how much is your V peak. In other words, your V peak is equals to V RMS multiplied by square root of 2. Be careful about that. When you do measurements, any measurements, your voltmeter always measures an RMS value. If it's an AC and you want to draw it, we only draw the peak value. We never draw an RMS value. Always multiply whatever you get with the square root of 2. That on its own tells us more about this. Always your meter, if you are in South Africa, the frequency is 50 hertz. What does that mean? It means this alternates between positive and negative 50 times in a second. In your textbook, you'll realize that they use 60 hertz. Be careful about that. It's because those are Americans, as you know. They like putting themselves in a different position from the rest of the world. Now, that on its own, again, brings me to something. I'm going to have a look at where do we combine AC and DC. When you have a circuit such as the one I'm going to draw now, this is your AC, and this is your DC. And I have a load connected. Without the DC, this is my DC, normally this is what you'll get if my DC is not connected. 2 cycles there. But because you have a DC, assuming this would be positive, this is my zero line, I have this DC here, a DC. I'm going to have something of this nature. Now looking at this tells me that I have a DC there, and this is my amplitude there. This point in here, we call it V maximum. V max. It is made out of V max, always made of VDC, VDC plus V peak. This point in here, again, it's V minimum, which is equals to VDC minus V peak. Now we're going to have a look at little calculations in here for you to go about them. Let's go over to the next slide. Now, again, I have a circuit which has got a DC and then an AC. This is 12 volts. Now this has got a V RMS of 20 volts, and I have a load. Look at this ground. I've got 2 grounds. What does that mean? It means this point and that point are connected. And I'm going to have a look. What is my output in here? V. If I have an oscilloscope and I'm measuring with it. Look at my supply. It's both AC and DC. What am I going to have? First, I must look at this VRMS, convert it to a peak. VRMS will be multiplied by square root of 2. Which is equals to 20 volts multiplied by square root of 2, which is equals to 28 comma something. I don't have a calculator with me, please complete it. Now, that is the voltage, your V peak. Now, we're going to have a look at something. What will you see on the oscilloscope? You're going to see a waveform which is like this. This is my zero line. This is my voltage. This would be my DC. VDC, which is 12 volts. Now I'm going to have something like this. It goes up there, and it comes down there. Now, this point is my V maximum. I calculate it also. V maximum is equals to VDC plus V peak, which is equals to, my VDC is 12 volts plus 28 volts, which gives me something in the region of 40 volts. That is my maximum. My minimum I can also calculate. This point in here, it's VDC minus V peak. This point in here, it's my minimum, V minimum. V minimum. My VDC is 12 volts minus 28 volts, which gives me something in the region of 16 volts. Now that voltage there, it's 16 volts. That voltage there, it's 38 volts. 40 volts, sorry, 40 volts. Now this is how you handle something which has got a positive voltage and it's got both AC and DC. Now let's have a look when we have a different scenario. A scenario whereby our voltage is negative. I have my AC supply, still the same value in this case, which is 20 volts RMS. I've got my DC, I've got my DC there, which when we look at it, it's how positive is connected to ground. My VDC, which is 12 volts. Now I have my load again connected to there, and I'm going to check here with my oscilloscope. Now you're going to get two values. First you're going to get your, this is my zero line. You're going to have a negative voltage because look at it, positive is connected to ground there. There it is. Now throwing it simply, you're going to have something of this nature. Using the same formulas that we used before, this is how you're going to go about it. This is your VDC. You see your VDC, your V maximum, or V minimum. V maximum is equals to V maximum, which is that point there, is equal to VDC plus V peak. Plus V peak. Now, what is our VCDC? It's how it is negative because look at it there. Our VDC is minus 12 volts plus 28 volts. Again, it gives us 16 volts. Now, that's my DC, it's positive 16 volts. My V minimum is that point there, the lowest value, which I can calculate. Let's say my V minimum is equals to VDC minus V peak. My VDC, we know that it's minus 12 minus 28, which gives me roughly minus 40. Therefore, this point in here, you've got to fully label it, it's minus 40. Now, what did we look at? We looked at a circuit whereby we have a two source of supply which has got DC and has got AC. So always be careful. Your two formulas are straightforward. It's V maximum. Maximum is equals to VDC minus V peak. Plus V peak, sorry. Plus V peak. V peak. My V minimum is equals to VDC minus V peak. Now these are very important formulas for you when you calculate and you want to draw. This is our output drawn. This is the calculations that you use, these two formulas in here. I hope and believe that you try to learn them, as they are not in any textbook, but they are very important for you. Now, another thing that I want to highlight for you is, my dear students, you are going to write all your tests here on campus. Please note, when you write a test here on campus, it will be marked. It will take a certain few days to mark it. But very, very important is, know that you've got to practice these problems that we try to do in here. And if you miss it and we want to write a supplementary, there'll be an opportunity for a supplementary. But please note, your supplementary will be more challenging than a normal class test, because you have been given more time to prepare. So if I'm you, I would definitely avoid a supplementary at all costs, or an extra test at all costs, because the supplementary is a little bit challenging. Now, there are some few things that I would like to have a look at them. One of them, we call it the E12 range. What is an E12 range? It's a set of resistors which are available off the shelf, but all of them have got a tolerance of 10%, meaning the last color is silver. Now, they come with the following standards. One ohm, 1,2 ohm, 2,2 ohms, and 2,7 ohms. There are 7 now. There are 6 now, sorry. 2,7 ohms, 3.3 ohms, 3.9 ohms, 4.7 ohms, 5.6 ohms, 6.8 ohms, and 8.2 ohms. Now, these resistors are off the shelf. Whenever sometimes you do your calculation, you find your answer being somewhere between 1,2 and 1,5. It is advisable that for better calculation, you've got to redo your problem. Instead of using 1,2, you'll use 1,5. And that is the way we do it. Now look at this 8,2. Assuming that you do your calculation, you find your answer is 9,2. You use the next one in line. After 8,2, the next one is 1 there. But for it, it would be like 10 ohms. In other words, these resistors are available in multiples of 10, of 100, of 1K, of 10K, of 100K, even of 1 mega. Now, be careful about that. You always look at it. Well, the next one after 8.2 is what? If it was 82, it will be 100. If it was 820, it would be how much? 1K or 1,000 ohms. So this is how we go about when we work with resistors and we want to know their E12 range. Let's assume again, make a hypothetical example here. If your answer was to be 3,7, which one would you use? Obviously, you use the next higher one, which is 3,9. And you redo your calculation for you to know that exactly what is the current and other parameters. Now, the next thing that we're going to have a look here are some few symbols that we must know. One of them is a fuse. Sometimes we do not no longer use a lot of fuses. We use in a power supply, we use a circuit breaker. That's the symbol of it. This is a fuse, and this is a circuit breaker. Now, Having looked at those symbols, these are not so familiar symbols. I would like to skip them a little bit. You have seen those, you know the switch, you know the battery. How do they look like? I would like to attend to transformers. Normally in electronics, we use a step-down transformer. What is a step-down transformer? It's a transformer on which this is our primary side, this is our secondary side. A transformer in which the secondary voltage is lower than the primary voltage. Now, that is the power in electronics. We never go like, but what helps us to know that it's what we call the turns ratio. Turns ratio. Now, it's normally symbolized with an N. It's given as N secondary over N primary. If this turns ratio is less than 1, it's a step-down transformer. But if it's bigger than 1, we do not use it again in our electronic section. It's actually a step-up transformer. In power engineering, they use it a lot. We do not use it at all in our power supply. Now, another formula for N class is this one. Sorry. N is equal to Vs divided by V primary. Now, what is Vs? It's a secondary voltage. What is Vp? It's a primary voltage. Since both N is equal to Ns, which is the secondary number of turns, over the primary number of turns, both are equal to N. We can say Ns over N prime must be equal to Vs over V prime. My dear students, this you can cross multiply in order to find out whichever unknown you don't have. Be careful, this would be like number of turns will be given here and number of turns. That tells you number of turns in the primary and number of turns in the secondary. Next page. Oh, yeah, that is. Okay. Now I'll have a look at this transformer. Now, it's a 10-to-1 ratio. Now, I have my voltage in here, which is my primary. My Vs would be simple. It would be like 220 volts divided by 10, which is the number of terms in the thing, in the primary. My answer would be straightforward. It would be 22 volts. Now, be careful. This value in here is what? It's an RMS value. If you're going to work on this circuit, you're going to work on an electronic circuit, you must convert this RMS value to a peak value. What do you do when you want to multiply, when you want to do that? To convert this to a V peak, you'll say V secondary multiplied by square root of 2. Now that's straightforward. You can do those calculations on your own. Always be careful. The given voltage, if not stipulated, whether it's a peak or it's an RMS, you've got to calculate it, or you assume it to be an RMS. Remember again the frequency. We are in South Africa. The frequency is how long? How much? 50 hertz, meaning 50 cycles per second. Now, again, I'm going to go over to another transformer in the next slide. I didn't see it. Thank you. In the next slide, here it is, we look at a transformer again. Now look at this is the primary side, and that's the secondary side. That's the primary, that's the secondary. This is our input, and this is our output. Now, very, very important, always look at the turns ratio. And again, very, very important is sometimes we have this type of a transformer. I'm now going to show you the secondary side only. Now, this type of a transformer, look at it. I have at the center there, I have tapped it. We call it a CenterTab transformer. Now, how does a CenterTab transformer work? A CenterTab transformer, what happens? The voltage which is in the secondary, which you use the same formula as before to calculate. What happens? The voltage here on this circuit, the voltage on this part of the circuit, it's actually V sec. The V sec that you calculated, by the way, divided by 2. Why do we say it's voltage V sec divided by 2? It's because at the center here, we did what? We tapped it at the center. Therefore, the voltage on the total is divided by 2. Again here, the voltage here would be V sec divided by 2. This one, if it goes positive, here, this side is how? Negative. If it goes negative here, it goes negative here, how does it go there? Positive. Look at this point, which is our center. It depends. If your point A is positive, how is it? Negative. If point B is how? Negative, how is it? Positive. In other words, the center depends at who's looking at it. Whether it's A or B looking at it, it actually varies whether it's positive or, but with respect to that. Now, that is a CenterTab transformer. We're going to use it a lot in our circuits in the immediate future. My dear students, let's recap. What did we look at? We first looked at zero as a reference point, which is ground. We looked at the positive one when DC is grounded. When positive is grounded, we got a negative, which is this part. But when negative is grounded, we get it as positive. Now, that's very, very important. We are recapping quickly. Now, in the next circuit, I looked at whatever voltage we have as an AC, what happens to it? It's actually whatever value they give to you, you must know, unless they stipulate that it's a peak value, you assume it to be RMS. The voltage at our plugs at our homes, they are set to be 220 volts. What is that? An RMS value. Always convert it by multiplied by square root of 2. Again, now we looked at it when we have DC and AC. We looked at it and we saw that our V maximum, the maximum voltage, it's VDC plus V peak all the time. But we're going to check how's our VDC. And look at this one. Our VDC was positive. When our VDC is positive, we add VAC. But the VAC that was given was an RMS value. What do you do to an RMS value to add it? You convert it to a peak first. That's very, very important. Our V minimum is VDC minus V peak. You do likewise. Now again, look at it. This is our minimum. So when our DC is how? Our DC is negative. Same circuit, but our DC is how? Negative. And you look at it, first draw your DC. I gave myself a lot of space below 0 there. I'm able to draw my output. My dear student, the next other thing that we ever looked at the E12 range. What is an E12 range? It's a set of 12 standard resistors which are available off the shelf. All of them, their tolerance is silver, meaning it is 10%. What are the values? 1 volt, 1,2 volts, 1,5 volts, 1,8 volts, 2,2, 2,7, 3,3, 3,9, 4,7, 5.6, 6.8, 8.2. These are available in multiples of 10, 100, 1K, 10K, 100K, 1 meg off the shelf. Now I'm going to have a look at the last thing for the day. Oh, well, I'm not going to add. I think this would be enough for you guys. Thank you.